Okay, we should be live now. Hi, everyone.
Hello.
Just to make sure that people are actually there, can you just post in the comment that you can hear us, that everything works fine? The streaming. Those 27 of you watching this. Hey, okay, thanks. Thanks, Bernhard. I guess this works, so I guess we can start. So once again, hi everyone. Welcome to our June session. Today we have a very special guest, Konrad Kokosa. It works, thanks. Konrad is a well-known speaker in the .NET community and also the author of a well-known book on .NET Performance, one of my favorite books, by the way. And he's going to talk about Blazor today, and I guess in his style, going like deep enough and showing us how the things work with Blazor. I would now hand over to Bernd for our standard introduction and the news about the group, and then to Konrad afterwards.
Thank you, Igor, for the introduction. So I will keep it short, but there are a few things to mention. This meetup today is sponsored by Microsoft, and I want to highlight two offers from Microsoft Austria. This is on the one hand side the Microsoft Discover workshops, and on the other side the Azure Dev Talks. If you open one of the links we posted here, you will find the Microsoft Discover workshops on this page. You will see different kind of workshops that are offered by Microsoft partners. So take a look if there's something interesting for you. And the second offer is the Microsoft Azure Dev Talks. So this is a regular podcast with a discussion about different topics. Igor and I had also the pleasure to participate in one of the Dev Talks about Blazor with our customer Andritz AG. And we talked here about porting a project from Angular to Blazor. So if you're interested, check out here this series of Azure Dev Talks. Then next thing, maybe you have noticed our Meetup group is also part of the .NET Foundation Meetup organization. So if you take a look at our Meetup page, you will see that our Meetup is sponsored by the .NET Foundation, and there are a lot of different meetups, and so you can take a look and find a lot of different meetups with topics about .NET in general. And just check it out, and you will see all these meetups worldwide and can join whatever you like. Okay, this is the .NET Foundation Virtual User Group, and that's it already from my side. And so there's nothing more to say, and we can finally start with the topic. So we can't wait to see what Konrad has to share with us. And Konrad, the stage is yours.
Maybe just one more remark. As always, we will have a Q&A session at the end. So please just ask your questions in the chat. If there is some really interesting question, maybe I will interrupt Konrad, but the talk will take roughly one hour. And after that, we will have a Q&A question. So feel free to ask your questions, bomb us in the chat. Thanks. So Konrad, please, the stage is yours.
Hello, everyone. Then, as I was introduced, I'm a .NET guy, so I really like .NET stuff in various forms. And recently, I discovered Blazor, and I thought it would be nice to share some findings and, in general, how it works and how it was created. So that's the goal for this presentation, and it is all about the project that I'm creating. In fact, I'm creating two projects in Blazor. One will be open sourced, one will be commercial one. Both are not yet publicly available, but we will return to that. So in general, maybe just a few words about me then. As you may know me already, and as Igor has said already, I'm an author of this book, Pro.NET Memory Management, which is over 2 kilograms about memory management in .NET, and in general, .NET freelancer, trainer, consultant, speaker, and I love really internals, performance, and so on. So that's the thing. I'm co-author of .NET OS initiative, which is all about the same thing. So we provide premium, let's say, content about .NET, like conferences, and we even met with Igor on our conference. We were thinking about how many years ago it was, because the time is passing by so fast. So it turns out it was 3 years ago at our .NET OS conference. And I'm also still prototyping this out-of-memory game, which is a game about .NET internals and performance, and it is a card game. So if you like card games, this is something for you, because it is all both for about Microsoft and .NET, and a card game. And it was a physical game, so you can go to this site and download it even, and print simply, because it is physical. So you need to download the PDFs, print them, cut them, and then you can play. There is a whole instruction how to play it. But I was thinking, okay, but that's pretty tiresome. Like, no one will probably do that. Like, no one will download it, no one will print it, and the potential of it is much bigger. So I thought, let's make an online game about the same thing. Let's create an online multiplayer game, which will be out of memory online game, and with the same rules and so on. And then the idea was to use Blazor, and that's why I'm talking here today, because I decided to use Blazor and I thought it's super nice and working. So that's the first project, out of memory, a game which is simply online game, will be online game, and it will be free as far as I planned today, and but also for sure it will be open sourced. So we also will be able to play with the source code, contribute, let's say, suggest new cards and so on, and all this in Blazor and other stuff that I will cover later on a little. So that's why Blazor. And in the end, if you are interested in such things that I'm doing, you can, for example, follow me on Twitter, and that's all about me. Recently, I published this pre-sale, pre-registration for the course, which is the next level after the book. If you don't like reading, or if you want to have some more interactive way of learning, and also with much more practical ways of learning about .NET Memory, there is .NET Memory Expert. You can look around, and that's the, let's say, marketing side. I will make a living from that, so I'm just a little excuse of saying about that. So coming to the presentation, let's say, Blazor, and I assume you know something about Blazor, because there was other talks about Blazor here, and there are many other talks about Blazor all around the world. But in general, just to have a super nice super fast introduction about Blazor, it was about being tired, let's say a little bit tired, of Angular, React, Vue, and other JavaScript frameworks. So you will be able to write something in .NET ecosystem instead. And that's the technology for .NET ecosystem going to frontend, I would say. So when we look at the definition, we will see that it is a framework to write rich web UI experience using HTML and CSS. That's still we need to use it, but instead of JavaScript, eventually we can use something different like C#, and that's super nice because we have all the tooling and other stuff. So there is this super popular demo about that stuff that was presented many times, and it was even something like that at the very beginning when the first prototype was shown. So this Blazor in general is single page application. And it is designed to be single page application, and there is this demo which is just showing us super awesome index page, hello world. There is a counter which just reacts to the button and increases the counter, and there is this weather forecast API being called somehow to simulate calling the server, database, whatever. And this demo is maybe not super sophisticated, but super nice thing about all that stuff is it is written in C#. And that's super important for .NET ecosystem, I believe, because we can write pages in C# simply. So how did it start? Because probably you all know the thing that the Blazor is and it works and so on, but the history of Blazor seems to be pretty interesting also. So Blazor was created as a kind of, let's say, playground prototype and showed at NDC Oslo. NDC is one of the most well-known conferences around .NET, Microsoft, although recently it is changing slowly, but pretty popular conference about software development in general. And Steven Sanderson was and he is still working in Microsoft. He was presenting this demo about various technologies that are coming to web applications. And one of those technologies, and there were some standard ones like using, as far as I remember, kind of localization or so. But he also showed the experiment, something for you to be amused by, something to show and see the reaction, whether people find it interesting or maybe totally not. So Blazor was a kind of experiment shown, as we see 4 years ago, we can say. Almost exactly 4 years ago, probably. So the goal was of this demo and to provide something that is more advanced, that is not advanced, but something that allows you to write the whole thing in C#. And what I found it super nice is also that the author of it, the Steve Sanderson, is not a guy that has come from nowhere, but he is an author of Knockout.js, super popular and well-written library for binding in JavaScript. So you have ever used Knockout.js. I was really impressed by this library, so I was super happy to see that this guy now created something new, which he has coined the name Blazor. And if you haven't watched that talk, it's really worth to see it, especially that part when he was presenting the Blazor. And for me, it was just a mind-blowing experience to see that he created that and that it works, because what the Steve has done there was to take a runtime, .NET runtime, which was called .NET Anywhere because it was the smallest working runtime available at that time. It was the runtime written by Chris Bacon, a guy from Google, that has written the whole .NET runtime in C because he wanted to, and he did it. So it was working, and it was pretty small. So it was pretty easy, let's say. Easy, maybe it's not a good word, but it was easier to use this runtime instead of something much more bigger than .NET Core, for example. And he took this runtime, .NET Anywhere, and recompiled it to WebAssembly to run simple console application that was printing hello world to the console in the browser. So what he literally did was he took this runtime, he recompiled the whole thing that was written in C to the WebAssembly, and he ran this runtime inside the browser. And then the simple console write line call was translated to printing something to the console in the browser. And that was something like mind-blowing experience, as I said, because it was the whole .NET runtime running in the browser in WebAssembly. So super nice. And also he presented the Blazor itself. So above this thing that was just printing something to the console, he presented the whole framework, the initial prototype of the Blazor framework that added the whole thing needed for making this a web app. So printing HTML, in JavaScript interrupt, in general, rendering Razor views, and so on and so on. So it was really impressive for me as a kind of demonstration of pretty mature technology. Like it was really working and it was doing what it was supposed to do. And so people were impressed, and Microsoft probably was also impressed. So internally, there was a hackathon next month that they were participating in, and they decided to play with this Blazor thing. So Microsoft itself and some people related to them has participated in this hackathon, playing with this Blazor prototype simply to see what is in the end possible. And since then, we hear about Blazor more and more and more, because it seems to be it is becoming pretty important technology for Microsoft. So since this 2017, we heard about Blazor many times in various conferences, .NET Conf, Build, and so on and so on. They were all the time announcements about Blazor being improved, being published, and so on and so on. And finally, in September 2019, one of the Blazor technologies was announced as available for production, let's say. It was Blazor Server. It was on the .NET Conf when the .NET Core 3 was announced also. And this Blazor Server was not exactly the thing that people were expecting. It is another technology that we will cover soon. But it was something that under the whole umbrella term of Blazor, because the whole Blazor since and during those 2 years has become something more than the demo that the Steve has presented. It was become kind of, let's say, architecture, how the runtime can cooperate with the other components to create web applications, and not only web applications as we see in the current announcements. And then only 1 year later, the Blazor WebAssembly was announced at the time of .NET Core 3.13, and that was the production-ready Blazor WebAssembly technology, which was eventually, after those 3 years, the thing that the Steve presented. And for me, Blazor WebAssembly particularly is the most interesting one, not the Blazor server, but the Blazor WebAssembly, because it is the whole technology that is running inside the browser, as we will explain soon. So that's like 1 year of being production ready since it was announced, and now we see the future of Blazor. Like more things are coming, like Blazor Desktop, Blazor Mobile, and I have a little bit elaboration about that later on, but we will see. That now it seems that the whole Blazor becomes pretty big stuff, which is covering various technologies under the same term. But today, mostly I would like to explain this difference and stay and concentrate on the Blazor WebAssembly. So first of all, Blazor Server, as this earlier technology, is a kind of client-server technology where all the logic of handling the user interface is inside the Blazor. We still call it a Blazor because it is, let's say, core of the whole concept. So we have this Blazor. It is responsible for rendering Razor views. It has all the handling of the UI handling and user interface events and so on, but it stays on server. It is hosted by a ASP.NET Core application, and the browser becomes super thin layer, which is just responsible, a kind of proxy, which is only passing some messages to the server, and it is just rendering responses from the server, but all things is happening on Blazor side. And we have this two-directional connection in form of signal R, which is just sending all the stuff. So the browser here is simply really thin proxy. If someone clicks something on the button, this message is going to through signal R to Blazor. The Blazor reacts to this event, calculates what should be changed, and informs the browser about the changes in DOM, let's say, in a kind of difference, what has been changed with respect to the previous state. So that's the Blazor server, and that's interesting technology. We must say there are use cases probably for that, because it is everything on server here, so that's nice. The browser is super thin layer, so there is nothing much happening in the browser in the end. The problem is about the signal R connectivity here, because if we are in a high latency scenarios, now we have a problem because the UI may become a little bit less responsive, because as I said, every reaction to everything that the user does is just sending, we are having round trip to server and then back. So if we have high latency, we will see some delays in the user interface itself because of the connectivity problems. So that's risky. The benefit is that the download size is small because the page is small. It is a thin proxy only. Everything is kept on server, so it is safe. You have full security. You don't have to be worried that someone will decompile something on the client side, while still it behaves kind of single page application. So we are somehow connecting both worlds here. And performance is also nice, like it is mostly the performance of the ASP.NET Core and Signal R, which is nice. So we should be not afraid of the performance itself and the scalability. But as I said, the problem is with the latency. So then what we should do, probably if we are in scenario when the users are using our app in high latency scenarios and environments, we should not use this technology. And obviously we don't have an offline support because everything is hosted and the whole communication needs server to react to anything, so we need to be online all the time. And for me, and that's kind of trademark quotation here, it is not that fancy. It is not the thing that Steve has shown. For me, it is kind of additional possibility, but not the one which I perceive as a super interesting. What I'm perceiving as super interesting is Blazor WebAssembly, which is super easy from the architectural point of view, because it is just the whole application being and running inside the browser. So we have the browser downloads all the stuff, downloads the whole application, and this application is executed client side. So we have fat client that in the end, if we don't have to, does not require any server communication, that doesn't require to be online because everything has been downloaded. So that's nice, and it can be hosted as you wish. So there are some benefits of that, and for my game particularly. So for example, fat client computation, because now we have fat client, which is just anyway sorry, whatever we want to have, we can calculate on the client. Everything will be written in C#, so it is nice. And we don't have to be worried about JavaScript and all the building of it and all the pipeline of handling JavaScript and so on. We everything have in C#, and it will be executed on client side. So it scales up indefinitely, in fact, because the clients are paying for our calculations. We don't pay because we are just offloading it to the client. So in the end, those calculations doesn't cost us nothing. So it is super nice. And what is else nice is that it compiles to static files. So you can compile your whole app, host it somewhere with the help of, for example, static web apps, and that's all. And hosting such static files is also much cheaper than the whole ASP.NET Core, for example, to host some SPA application. So that's super nice also, benefit of that. And obviously it may support offline if we don't need to communicate with an API or server, and then it may just work offline and we don't care. So that's nice. And obviously those benefits can be somehow said that, okay, that everything here is the same for fat clients written in JavaScript or TypeScript. That's true, but for me that's not the benefit, because I don't particularly like JavaScript or TypeScript, and now I have everything in C#, and I can share everything between the client and server. I can have some data structures being shared between client and server. I can have algorithms that are shared between client and server. Everything is in C#, everything can be shared if I want to. So that's super nice. Everything is in .NET. Unfortunately, there are some problems currently. The first problem is about payload and overall size of the page, because we need to download in the end the whole runtime, as I explained. So that may increase the size of your page. And also currently the speed is, sometimes people are complaining about the speed, because everything is running in the interpreted mode, as I will cover. So that's not the thing for probably for super CPU intensive calculations. But on the other hand, probably clients in the end are not super CPU intensive applications, so that not every time needs to be a problem. And by the way, both problems are going to be addressed by Microsoft. They are thinking about it. They are aware of that. So .NET 6 has some announcement, and I will cover that later on. So in the end, because the introduction is, let's say, long, there are not so many applications written in Blazor WebAssembly. Especially in like production ready, production available manner. I've met one company in Poland which is writing this Modelution software, which is for modeling software with the help of the UI based application. And here this modeling is happening in a mode which is using Blazor WebAssembly, and they found it super convenient because they are implementing the whole thing with the help of event sourcing. So event sourcing is nice because now they have possibility to make calculations and projections, and everything may be done both on client or client. The decision is theirs, so they can easily move calculating some things from server to client, and they will offload the calculations obviously, and then they will again benefit from the cost, because the client is paying by the CPU power and not you by your hosting payments. So that's one of the examples of applications that you can see, and probably you will be able to see, because as far as I know, that's something to be published in few weeks, days, maybe in a month or two. So you can look around, and then you will have an opportunity to see something that is production ready, really written in Blazor WebAssembly. Okay, so just a few words about the WebAssembly itself, because I'm saying WebAssembly, 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 but what in the end this WebAssembly is. So a little bit of a history again, because I really like to explain things, not only what they do, but how they were created and how they are invented and so on, because it helps us to understand things. So in general, the concept of WebAssembly is to run code on browser, on the client side in the browser efficiently. We want to execute code on the browser. Obviously, since many years, we need interactive applications. So if you want to execute some code on the browser, on the client side, the JavaScript is the obvious choice, and the JavaScript is the king, and we know all that. But there were other attempts, like everyone remembers probably, rest in peace, Adobe Flash or Silverlight from Microsoft. So they were technologies addressing similar problems. They were about a little bit different scenarios, at least at the beginning, because they were about interactive, nice graphical things with animations and so on, at least in case of the Adobe Flash. And Silverlight was something that was trying to be plugin for hosting .NET applications with the nice user interfaces too. And the problem with both of those approaches was that there was a plugin for a commercial product in the end, because both they were available for free. They were driven by a single company that was somehow, driving this project by itself, let's say. And in the end, they were plugins, and we because of the security reasons, we are afraid of plugins, because plugin may do everything in the browser in the end, so it may be very harmful. So there was this the gap between the JavaScript that is okay, and it allows us to do a lot of things, but it is not super efficient, mostly because it was not written from the scratch to be efficient, and that's by default, let's say. And on the other hand, we had plugins which were just insecure. So the WebAssembly was an idea, but before that even, people tried to fill this gap somehow. What could be done to run efficient code on the client side? And there were some super interesting projects that I wanted to mention, because this is a talk by me, so I am always giving myself kind of a privilege to talk about low-level stuff, let's say. So there was a project which is called ASM.js. It was a transpiler from C and C++ to JavaScript. And that's something that is really scary when you see that idea. But in the end, it was, and it still works really nicely. So the idea was, okay, we have a lot of nice programs written in C or C++, like games, for example. And what if we could recompile this code to JavaScript and then execute it client side? Sorry. So there is this compiler which is called mscripten. It is based on the super powerful toolset for compilers called LLVM. And it was working pretty nicely. You can even now use this mscripten for recompiling your C or C++ project to JavaScript. It was working pretty, let's say, surprisingly well, because this JavaScript that has been produced by this tool was really efficient in terms of it was the code fine-tuned for performance, for example, and for sure it was not the code that the regular JavaScript programmer would write. So, for example, it was the zero alloc JavaScript, because we were recompiling things from the C or C++. So, from the languages that doesn't have automatic memory management. So the JavaScript could do a similar thing. They can just pre-allocate huge buffer, let's say byte array, and use it as a memory. Without any GC, because everything was pre-allocated. Also, there was some tricks for better handling of types, and in the end, that was working. So we can play Doom with the help of it. Unfortunately, it is still now loading, but as you see in interactive, you can see here Doom that was recompiled from C++ to JavaScript, and it is running in our browsers currently, really without any delays. So that's pretty impressive. And this project was, in the end, is still pretty impressive. It was able to hit half of the native speed. So pretty close to the native speed of applications. So there is freedom. There is even the DOS emulator that you can use and run in browser with the help of this project. But it seems as a scary idea in the end, and it was postponed and deprecated in favor of WebAssembly that was introduced in the meantime. The same idea was created by Google, so they wanted to create something that will be able to run any native application in a sandbox inside the browser. So it seems like kind of plugin that will be really sandboxed, so it will be secure and so on and so on. And the goal was to execute any code that is, for example, Intel, or even the ARM code, or even the LLVM directly intermediate representation of the binary code of the LLVM itself. So it was designed to be pretty flexible, but it was a Google project, Google's project. So in the end, it was also deprecated in favor of WebAssembly, because the nice thing is, and what I'm trying to say here is that there were approaches to this problem from various points, from various even important players like Google, that tries to solve this problem. But happily and fortunately, this WebAssembly standard was created. So the huge benefit of it is that WebAssembly is standardized. It is not a project driven by Microsoft, Google, or anywhere else, or on any community. It is simply standardized by the proper bodies, let's say, a binary instruction for a stack-based virtual machine. So it is kind of IL in .NET. If you know .NET, IL is an intermediate language describing your program in an abstract instructions for an abstract machine that it then will be somehow interpreted or recompiled to native code. So WebAssembly is something really similar. So we have some set of instructions that describe your application in term and to be executed by some virtual machine that is stack based. And then there is only the choices of particular browser how this WebAssembly should be executed. The thing is that it was from the very beginning designed to be fast. Like, it was designed to execute applications in browsers in the almost native speed. So the whole concept here is just for that. It was designed to be portable, and then to be fast. And those instructions should allow to execute your application in a fast manner. So the first goal here, and the standard that is already agreed, is that you have possibility to compile your low-level or high-level languages, because low-level for me is assembly, and C++ is intermediate level, or let's say high level even. So you can take any program that is written in C, C++, Rust, any native application in the end, and compile it to this WebAssembly format, and then it will be executed by the engine, which is just embedded in the browser. So the browser will be able to execute this WebAssembly, and it will be they should be able to do that in a highly optimized manner, because that's the goal. So we really need to understand that, because I sometimes see some confusion, because now we have two runtimes in the end and two intermediate languages, because we have .NET, which is just the whole ecosystem, and the .NET in the end compiles C#, F#, whatever language to intermediate language, which is then executed by .NET runtime. So that's the first first managed runtime that we have in mind. And on the other hand, we have WebAssembly, which is the second managed runtime, which is able to execute in browser the WebAssembly code, those binary instructions created for the separate virtual machines that will be executed by the managed runtime of WebAssembly. We can call it probably WebAssembly managed runtime. So we have two managed runtimes, and how it is cooperating in the end. So let's move to the Blazor part. The thing is, and what Steve has shown you and us in the NDC talk, we want to run C# code. So we need .NET runtime to do that. But WebAssembly is generated from unmanaged languages, like I said, from C, C++, and Rust. So although this is slowly changing, and kind of spoiler, that's not totally true here, but let's say and assume, and especially 3 years ago it was true, we were limited to compile only unmanaged languages to WebAssembly. So we have C or C++ program, and then we can manage to do that, to compile it in WebAssembly. So what Steve has done was to compile the whole runtime, and that's again needs emphasizing because that's mind-blowing. He took the whole runtime, which is written in C, and compiled it to WebAssembly, which was this .NET or Anywhere at the beginning. But it was too limited, so decision was pretty fast to change it to Mono, because Mono is a language, is a runtime which was for the very beginning designed to be multi-platform, in opposite to .NET Framework and all the consequences when it was ported to .NET Core. So, for example, Mono has much better interpreter, which was well tested, because Mono was used for Xamarin, and Xamarin was used for iOS, and iOS is not allowing to JITAS, so we need to interpret. So in the end, interpreter in Mono was pretty nicely working, and it was available out of the box. So now the Mono is being used when you use Blazor WebAssembly. And that's how the final process looks. So at the pre-build time, you compile the whole runtime to WebAssembly. Obviously, we don't need to do that, and that's good because it takes a lot of time. And we have Mono compiled to WebAssembly. Then during the build time, we simply built our .NET app as any regular application, with obviously some dependencies which allows us to use Razor views and makes all this application a Blazor application, but it is a regular compilation. All the assemblies are compiled to the IL code, and they are producing assembly files as any other build for .NET application. And then when the runtime starts, when we go on to the page, which is just hosting Blazor WebAssembly, there is this bootstrapping JavaScript that downloads and executes this Mono, which is running in WebAssembly. And so now we have this first stage in which we run the whole runtime being executed by the first runtime, the runtime being able to execute WebAssembly, which thanks to that we have running .NET runtime inside the browser. And because it is a regular .NET application, regular .NET runtime, it is able, and with the help of this JavaScript bootstrapper, it is able to download all additional dependencies, like the all assemblies required for your application, and then the runtime starts executing this code. So you have the DLLs. Inside those DLLs, you have an assembly. Inside this assembly, you have a regular IL for your application. And Mono, with the help of interpreter, is starting to simply execute it instruction by instruction. And that's one of the, let's say, problems of the current approach, is that unfortunately we need to interpret it. So we look inside our assembly, and instruction by instruction, to be more specific, IL instruction by IL instruction, we are executing our application in interpreted mode. And that's pretty a lot of work, as you see, but what is nice, that it is simply working. So if we go to a sample site that we would be, and this hosting in the end the application in Blazor, I don't want to use, okay, so we will see here that when we go to this page, a lot of stuff is being downloaded. So we see here that although this application is really a simple application, as in any demo that is presenting Blazor, we see a lot of those resources being downloaded. So we see bootstrap of the whole Blazor hosting, let's say, that will be able to start executing the mono runtime itself. And obviously it is a little bit of cryptic here because it is maybe not minified, but at least not all the names are super readable. But what we see in the end is that this mono runtime is downloaded. So we have the mono.js bootstrapper that is kick-offing our mono runtime, which is mono.wasm, and that's exactly what I said. It is the whole runtime being compiled to the WebAssembly, and then because our app starts to execute, we see that it is here the DLL, the assembly itself, that it starts to contains our application all together with all the dependencies. So we see that out of the sudden, our page starts to download all the DLLs of regular .NET applications. And they contain IL code as a regular .NET application. So if we see inside the micro app DLL, which is the main assembly for this particular application, and when we look inside the result, the content of this file, we see simply that it is in the end a regular DLL that it could be even used in the console application. It starts with those name M and Z, which means simply it is an executable library, the DLL library for Windows application. And we see even this message that is in every application that is be to execute it inside Windows. So this is a regular library that is being used because Mono is simply not downloading, but is simply populated with this DLL and starts to execute it. So pretty sophisticated things are happening here in the end because we need to do a lot of kickstarting, let's say, and then imagine that this mono, which is now interpreting various things, we need to interpret a lot of code because it needs to interpret our application, which will call probably a lot of other dependencies. So we start to interpret Linku and other collections and other libraries that are just all together going to be used with our application. So in the end, if you realize how much things is happening here underneath, I'm still pretty impressed by the speed. Like, it is really working nicely, taking into consideration how much stuff is going underneath. So in the end, the Blazor, and what I like it the most is it is maybe hosted in standalone mode. Obviously, you can host it in by ASP.NET Core. Your mileage may vary because it is up to you how you host it. So you can host some static files from ASP.NET Core app, but standalone hosting is super nice. And that's because I really need this connection of technologies. So if we can host everything statically, we can use static web apps, and we have a client which will execute some code on the client side. And if I need an API, I can use other functions, and then I have this super nice combination of technologies which are super scalable. They are pretty cheap if you are hosting it wisely, and you don't have any server to host your application, which consists of those elements. That's super nice. And that's exactly what I'm using for this out-of-memory game. If you would like to play with that, that was probably even presented before when the Blazor was presented at the talks here. So there is a template that you can use for exactly such kind of deployments there, where you have WebAssembly application, which is just calling some Azure functions with some additional shared library inside. And then you can create static web app inside the Azure portal, and there is a preset that will configure everything, so you will be able to work with that out of the box. And I really like it. So in the end, my particular game looks like that, at least at the moment. Probably I will add some more elements here, but currently it looks like that. So I have my web application, which is a game, which is Blazor WebAssembly, which is written in C#, which I like, and it is being downloaded to the client, and it is then inside the browser, and everything happens there. I need some authorization, so I'm using also authorization as a service. Currently, I'm using Auth0 service to do that. I will think maybe I will use something else. But it doesn't matter. What is important that I don't need anything and again, I don't need server to make authorizations. And then I get some kind of authorization providers, a provider that will allow me to authorize myself. So for example, then obviously my application is an online game, so I need a kind of communication with a server, and this server is just an API exposed by Azure Functions. So for example, every time a player plays a card, there is a command for a particular Azure function that to issue this command that a player wants to play a card. So there is an API on that level with the token that I obtained from the authorization provider, and then I store the whole the state of it is persisted in Cosmos DB. So the whole truth about the current state of the game is in Cosmos DB, because why not? Like Cosmos DB is another nice fancy stuff that we can play with. So, and also super scalable. So if I will succeed with this project and millions of people will start to play, I have scalable technology at hand, at least, with the database also. And because I have a command here that is issuing, I'm issuing a command to the Azure Functions, I'm calculating what is the state update of the game, and then I have some events that will inform all the players what happened, including the player that has issued the command, whether it was, what are the effects of this command. And for that, I have this bidirectional communication with the help of SignalR. I have SignalR service for that, which will be just all, again, in a scalable manner, able to inform the clients, the connected clients, about the updates of the game. So they will be events coming from the SignalR to the client, which almost all the time they will be issued by the Azure Functions, just informing about the consequences of a command. So what I like here is that obviously that everything here could be written in JavaScript. For example, if I would be pretty proficient in JavaScript, probably the client could be written in JavaScript, but it would mean that everything here and the whole logic of the reaction to the event, the whole logic of issuing a command would be written in JavaScript. Moreover, I need to share some definitions of card, of the game, because that's pretty convenient, and then I would need to somehow duplicate it or serialize to JSON to get it to the client and so on. So I don't need that, because I can have a shared library which just informs and is embedded both in the client and server, not the server, but Azure Functions, and that what is the definition of the current game, like what are the cards, what are the rules of the cards, what are the consequences, and so on and so on. So that's super nice thing, and everything here is in C#. So again, for me it is super nice. But the question is whether I was really be able to get rid of JavaScript. And the question is whether it is in general possible. So for sure, Microsoft really tries to force, and maybe not force, but encouraged to use Blazor in that manner, so you will not use JavaScript at all, because if you have a lot of components, a lot of community-driven components for various things like calendars, date pickers, even graphs, and so on. So for most of your needs, probably you will find already some component, and the commercial companies like DevExpress, for example, also already provides paid components for the Blazor. But unfortunately, sometimes there are some components that you need still to write somehow, and probably you will not do that from scratch, but you will be interested in somehow reusing already existing JavaScript library, because probably there is already something in JavaScript that is already available. So there are some projects like Charge.js is wrapping the popular Charge.js library inside the Blazor component. So now you can just download it as additional NuGet and start to use this component. That's nice. What I was forced to do was, unfortunately or fortunately, because it is some fun, to wrap additional library which is not already wrapped inside any component for Blazor, which is called Phaser.io, because out of memory game is a game, so it requires some animations, fancy movements of card, and so on. So I would really not be willing to write it from scratch in JavaScript or even in Blazor. So I decided to use Phaser.io as a well-tested, really nice library for writing something in the client with the help of JavaScript. So we're returning to the JS interop, because I have a Phaser.io which is just doing some drawings, and I need to wrap it and somehow communicate with my Blazor code inside, which is written in C#. And for that we have JS interop, and I will show you in a minute just a super simple flow how it is happening. But luckily Blazor is providing us this JavaScript interop, so you can wrap around somehow JavaScript component and communicate in both sides with your C# code. That's nice. So that's a kind of, because I would like more to show you some code instead of describing the, let's say, strategy of the Microsoft. But the goal for Microsoft is simply to make Blazor faster and faster and smaller to address those two problems that I have described previously, because they want to give you something that will be able to fight for attention with people not only from .NET ecosystem but from everywhere when the front-end technologies are used. So they're really trying to think about fighting with JavaScript. We will see. For sure, to do that, they need to improve the speed, and for that they are introducing IoT technology, which is coming to .NET 6. And that's something that I really like also, because it is something which will really change how your application is running. Because as I described it so far, we have this interpreter inside which interprets your application, because we need somehow to execute the IL code. But the IoT technology, which is just a shortcut for ahead of time compilation, is super nice technology that will compile the whole application, the whole .NET application, to the WebAssembly during compilation ahead of time. So the whole application will be prepared in form of WebAssembly. And that's why I said that's not entirely true that only unmanaged languages can be compiled to WebAssembly. So since .NET 6 Preview 4, already, we can play with these technologies in which not only the mono is compiled to WebAssembly, but all .NET assemblies that we would like to use are also compiled to WebAssembly, which is again next level of mind-blownness, because it is not trivial. Like if you think about C# and EIL that is produced by C#, then you need somehow to translate all the intermediate language instructions to the WebAssembly instructions that will additionally call WebAssembly code from the runtime itself. So it is really not trivial, but Mono is able to do that eventually, so we will have this technology. There will be no JIT, there will be no interpreter, simply the whole application will be already in form of WebAssembly that will be executed by the browser. That's super nice, and I'm really interested also how it will speed up things in terms of my game. Unfortunately, I was not able to do that so far, but I saw already some benchmarks that the speed up is orders of magnitude, because getting rid of interpreter and having having your application executed in WebAssembly directly really can produce a lot of speed up at that stage. So .NET 6 Preview 4 in the end, I have a typo here, at least I believe it starts to really work in Preview 4, so you can find it if you have any .NET Blazor apps and try to play with it. Okay, I would like to show you only some code, so just one slide about the future of the Blazor, because I said we have Blazor WebAssembly, we have Blazor Server, but recently Microsoft starts to talk a lot about the future of Blazor, which is about desktop applications, because now under this umbrella term of Blazor, they see the space for improvements, how the Blazor can be incorporated for desktop applications and mobile applications. Because what the Blazor in the end is this split between the Blazor, which is the core about the UI handling, and the layer of interpreting and let's say printing, showing you, displaying you those changes. And this client server split in terms of architecture is allowing to move it to a desktop also. So we see not only Blazor progressive web apps, which is just a kind of small extension around the regular application, but we saw, and the Microsoft is showing previews of Blazor desktop. You can play around it already. So you have it appears as a native application. It is something like Electron in terms of JavaScript word. So you have a native application, which is just have all these frames and the title bar and so on. But the difference is that inside this application, you have an embedded Blazor web server. And then inside this application, you have a control, which is just an HTML drawing control. And because of that, you have the Blazor the Blazor server inside your single application that is just providing you a native capabilities like any native desktop application. So it is kind of hybrid solution, and it really assembles the Electron technology, which is then used in the same manner. So that's the technology that Microsoft is now presenting, and it is targeting .NET 6 for making it available as far as I know. And also Blazor native, because if we can change the presenting layer to anything else, the next step would be not to render HTML, but render the native UI of a specific platform. So Android, iOS have some libraries for rendering, obviously rendering controls and the whole UI. So the next step would be to exchange it from HTML to be able to render native look and native UI of the app with the same architecture. So Blazor web server probably embedded, and then UI rendered in the native technologies. So that's the whole technology that is going, and we will see it covers a lot of possibilities. We have Blazor web server, we have Blazor WebAssembly, hybrid solutions, which is also known desktop, and in future also native for rendering native apps. So it seems that it is pretty there is a chance it will be popular technology. Like it will survive longer than Silverlight, that was created for a specific particular use case that unfortunately didn't work. And maybe now the future of Blazor is a little bit better than the future of Silverlight, for example. And above all that, we have the support for ahead of time compilation, so the speed of it should be also pretty nice. So I'm really hoping this technology will evolve to something that will stay in .NET ecosystem and will not be only kind of experiment that people forget about in few years. And just to show you this interop, because this whole application will be open sourced, but it still needs a lot of code to be added. So I'm not having here a lot of code that I'm super proud of already. But one thing I would like to show you is this interop, because this is the thing that is pretty interesting, how things cooperate. So that, and one more thing just to emphasize, it is not a regular way in which we should program in Blazor. That it really needs to be shot out here to not mislead you. So when you program in Blazor, typically you should use only components. So like, for example, the chat example that is somehow still in the repository because I haven't deleted it yet. That's the typical code when you program in Blazor. You have a code in the Razor view. You are injecting some additional dependencies. Everything is HTML. Everything is just a view. And then you inject some reaction, you inject some comments, you set some parameters via properties, and then you can have code behind that will be responsible for handling some additional logic. That's the typical way, obviously, if you are lucky and you have those components already available. I don't have them available for this Phaser IO, so in my case, I'm creating this layer of presenting the game with the help of Phaser IO. That will contain some code only for presenting reactions to events. So unfortunately, this code still needs some polishing, but was like, let's say, one of examples here is that where it is. Okay, so here, when I'm creating a card that the player can use, obviously the player can drag and drop cards, as I will show you in a minute. And when the dragging ends, I'm invoking a code from my Blazor code. So when here we are inside the JavaScript, and this is just passing the comment, let's say, the fact that the card has been dropped somewhere, and this event then will be passed to the client, like not the client, but the code behind, let's say, here. And in the end, the C# code will be executed on the client side that will be responsible for handling that. And for me, that's super nice because I can validate some things at that moment on the client side, as I said, without paying. And then I can just send the comment and wait for result and so on and so on. So that's the plumbing that you can have from the JavaScript to the code behind written in C#. unfortunately currently requires some plumbing, because to make it easy, we need to use static field. So in the end, we are calling static event static method that is just calling a function that is wrapping our method here. So it requires some unfortunate plumbing that I don't like. That's why I plan to make code source generator to plumb it automatically. So every method that will be that I will make with this attribute will produce this plumbing, and that it will be available from the clients from the JavaScript. But that's, let's say, second level of improvements. And from this this interop probably would be also nice to follow how it is working, but in the end the thing is simply working, and that's important at that moment, maybe without getting even further. And what's nice, we have also this second direction. So then I was calling JavaScript, from JavaScript I was calling C# code, but from the C# code I can call also any code in the JavaScript. It also supports modules, so it is maybe pretty nicely organized. So I'm calling from a particular module inside my JavaScript client code a particular method, and then I can pass parameters, and JavaScript interop will do the magic, will find this method inside my module, and it will be called, and so on. So that's working in both directions. And I really, probably in a few months, I can give a second talk about only this layer, because it will be really nice, experience to produce and consume JavaScript only as a super thin layer that will be responsible for calling phaser IO methods like move an object, add an effect, stop an effect, and so on and so on. But that will be super thin layer of the JavaScript inside the game, and the whole logic will be happening inside C#, because that's I like to have. And just to show you the current state, there is this Blazor that is being hosted statically, and there is this Azure functions that are for games, and I can join some game by hand currently, and that how the game will look. So when the game is presented here from the client perspective, from player one perspective, I can play some cards, I can drop those cards. Unfortunately, this move is not legal at this stage, so I'm getting information about that. Obviously, I will have also a lot of nice play with the user interface and making it fancy with all the animations, but that's the last stage probably, because the most important part here is the core logic. Okay, we are should probably slowly end, because we are above 1 hour of the talk, and I am also seeing some questions. So to give some room for questions, let's stop at that moment. Just as I said, all this will be open source. So if you find it interesting, stay tuned, and you will have an opportunity to download it and play yourself.
Good, thanks, Konrad. To the game, I can say only one thing: ship it.
Yeah.
No, it is not just just press the publish button. Good. Thanks for the talk. It was very interesting. I also have a couple of remarks, but let's go through those which are asked in the chat first.
Okay.
They cover different aspects, and also for the others. So there's still 40 plus people here. If you're interested in something, please feel free to ask questions. There was just one small remark from Bernd that the newest version, these files are renamed. Yeah, so
that's
thanks,
true.
Bernd.
That's true.
Yeah. The one from Tanvir is very interesting. It's actually an architectural question in general. So you were talking about this nice thing that you do not need a server, which is a great benefit and so on. And interesting thing is this, the performance or scalability in both directions. So if you can add a word or two on that.
Yeah, so in general, as what I find nice is that if the Blazor WebAssembly app will be running good enough, and after IoT technology, probably it will. I really don't care about that because it is the client executing it, so I only need to make sure it will be smooth enough, and probably it is already, so it will be. So at the client side, there is no problem about both vertical or horizontal scalability. On the server side, let's say API side, obviously, I'm really counting on the scalability of Azure Functions. So if there will be bigger load, I will be able to scale it simply to handle that, and that's the main approach that I will try to take. Obviously, I'm also performance, let's say, twisted, so I will benchmark it for sure. So it will be try to be efficient from the day zero, but that's the, let's say, second story, like not trying to allocate there like a crazy or so. But currently the logic is pretty easy, and I don't feel a need for any sophisticated optimizations there. But for sure, I will keep in mind about that. So the main problem here I see is the scalability of SignalR, which may be pretty costly, and I need to simply think about that in future, whether it will just be worth to use this particular service for this solution. Because as far as I remember from my calculations, the main cost may come from this or from Cosmos DB, but mainly from a SignalR service. So if not SignalR, maybe paying for Azure hosted, simply ASP.NET Core hosted apps that will be Azure, also SignalR hubs will be just enough. But I must admit, I'm not thinking about that as much now because I really don't know if anyone will play this game. So, I don't like this quotation, premature optimization at this moment may be a
But it's an interesting question in general, definitely.
Yeah,
so to
absolutely.
explain a bit, I think
that's
the use
I
cases
believe opens a door for a second talk, like how we can approach that. But yeah.
And maybe a question which goes in the same direction. I'm personally a huge fan of this as a Jamstack and also like static pages and so on. And most of the things I do, at least from my part, I'm trying to follow that path. And it's interesting how Blazor WebAssembly fits into that. So question from Cass, is it possible to load a single Blazor component within some static HTML or multiple components? Now, I'll let you answer because you show already on your slides how it works in the case of WebAssembly Blazor. Of course, server side, it's not. But there was this interesting part for me also for thinking in a Jamstack direction, this equation which you had, like plus Azure Functions plus and so on, serverless. So if you can please reflect on this one.
Yeah, so I believe it is like what is currently done, that we are using just this Blazor template out of the Visual Studio, so it is all plugged by default, and there is this bootstrapper in JavaScript that is plugging all the connecting all the dots, let's say, but I don't see any problem to make it more flexible, so you will be able to plug it inside like a single component inside a static HTML. Why not? Sure, but then probably you will need to modify a little bit this whole machinery, the bootstrapper that is plugging the whole thing. As far as I know, it is not yet supported to do something like that out of the box. for sure you simply need to have all the stuff still. So you need to have this mono WebAssembly being downloaded and executed. The manner is here how it will be kickstarted and which parts will be handled by this. But I believe it is possible. I haven't seen any such thing, like any article even.
Maybe to that, what's possible and what's not. This is an interesting practical question. Like, yes, we have C# and it looks like a regular C# development, but still the code is sandbox within a browser, at least WebAssembly. And this is an interesting question. Like, what API surface does the runtime cover? It's like standard 2.0. What can be done and what not? You know, like if you have an example like HTTP client and then do something, what happens in the background, what works or not? If you have experience on that.
That's indeed interesting question. So the standard by Mono, I believe, is 2.0, unfortunately. But because when we are using Blazor, Blazor WebAssembly, because I believe we are talking here about Blazor WebAssembly, it is Mono. So it is just the .NET standard supported by Mono. I'm not 100% sure here, but I would say 97% I'm sure that it is still standard 2.0. So it is the API surface that you have there. And the sandboxing stuff, it is .NET runtime. So I believe you can open .NET, you can open TCP sockets. I haven't tested it yet. I don't know. But I don't know. Like probably the easiest way would be just to try it for this particular case.
Yeah.
But to have more general answer, what is limited? Let me think, because for sure some APIs are just pipeline to the browser. So when you use console write line, you are writing to the console of the browser. If you will try to open a socket, now I'm thinking whether browser is able to open
it will not allow it. Yeah.
Probably not. So for sure the answer is it is sandboxed to everything that the browser can do. But then I'm not sure what the browser really can do nowadays, because those standards are so fastly changing. So unfortunately, I don't know the full answer. And also don't remember an article stating a list of those limitations. So unfortunately, you must leave you with some unanswered question.
But I think what we for sure can say this, because it is handled by the browser, limitations will be there. Like, and
exactly.
which level to an API? It's a good question. Yeah.
Like for example, writing to a file, no, because there is no access to the file. If you cannot do it in JavaScript, you will be not able to do that in Blazor WebAssembly also.
Yeah, simple answer. One question, which is I'm very interested in this question actually. So if thanks Andrei for placing the question. If he didn't ask it, I would ask it. So Konrad, you were mentioning Blazor desktop, and I again have this feeling that Microsoft is, like again creating a competition to its own technology, and we will again be puzzled. Okay, what should I do now? I want to start a new desktop development. Yes, there are still people doing that actually, believe it or not. And MAUI is coming, yeah, and it's heavily like advocated by Microsoft and so on. And on the other side, they're talking about Blazor desktop, for example. So how do you see the future of both, or the relationship between them, or combining them?
That's one of the trickiest questions I can imagine, because I have the same feeling as you. So I'm even get lost in all those propositions. What in the end is the suggested way of developing a desktop app? Like for sure, MAUI, or however it is pronounced, is the way, but I perceive Blazor. Maybe answer let's start from answering the first question. So there is this relationship that you can embed Blazor desktop inside MUI applications. So you can write, in other words, you can write and add Blazor components there, Blazor host, however you will call it. So your app may be written in a Blazor desktop being hosted by .NET MUI. Why? I'm not sure.
Maui.
Maui.
Yeah,
Okay, that's pretty tough.
yeah.
So it can be done, and it was even presented during the build, or maybe there is a blog post about that. So your application may do that. And I see it probably not as the mainstream way of doing desktop apps, but probably in the case when you have a Blazor as your technology stack, and then you will have, for example, Blazor mobile, and then you will be able to use it also as a Blazor desktop app, and also Blazor progressive web apps. So kind of, if you stay with Blazor, you can use it with the .NET MUI. If not, probably you will use this technology without Blazor simply. So it is, I'm seeing it is a kind of intersection of two worlds, and I don't really know what will be the final answer, how we, in the end, we should develop our desktop apps. That's the problem even for the whole, the MUI itself, because it doesn't support Linux. So for me, it is partially multi-platform UI technology. And when I was recently looking for one, I just decided to use Avalonia, because it was just the one that is answering my simple need. Desktop app, native desktop app for Windows, Mac, and Linux, period. No magic, no mobiles, no progressive web apps. But I don't know. Sorry for that, but I don't know.
It's a tough thing. Actually, nobody knows.
Yeah.
I remember ever since that, when WPF was kind of dead before the .NET Core, people were asking constantly, like, tell us what to use for desktop development, because people are still doing it. Maybe to reflect on this, here is Gordon saying, well, they have a desktop app, and they have things which can be done obviously only in desktop app. So they will going to stay. The trend is clear, going toward web, but this clear answer to what should we use for desktop development, it's not that easy. But let's go maybe to some easier questions, at least the technical ones, because this is what's going to be. What's going to be in the future. It's difficult, but this is a thanks, Paul, for asking a very practical question. Can you debug your C# Blazor WebAssembly code?
You can.
Browser DevTools?
Absolutely. So in general, when you execute, start to run your Blazor WebAssembly app, in background, the debug server is also running, and it is just a proxy between the browser and the Visual Studio and the application itself. So in the end, what you can do is to set breakpoints both in browser and in Visual Studio, and then it will stop. For example, if you set a breakpoint in the DevTools, you will see also that Visual Studio has stopped at the same line on the same file. So they cooperate. So the goal is, it is possible. That's the short answer. The longer one is that it is not always stable. Like, we should remember, it is still preview. So I really used to the fact that sometimes the breakpoints doesn't work simply, and I need to restart the app. So that's maybe not the super nice, but I'm just saying, okay, that's preview, and especially I'm using the newest preview, so let's not blame the preview version for that. For sure, Microsoft is, the whole thing is here waiting for being polished, but in general, this is working, should be working.
So short answer, yes. Longer answer, potentially not the best experience. Please, if you have any other questions, just type them in. Also, maybe I have a few of my own. But meanwhile, we can ask this one. This is a business-related question, a serious one. Okay, so I mean, maybe you don't have to disclose it. If it's a confidential, the game is still not out. I said ship it. You definitely should. But so what was the cost of that infrastructure? showed us.
I made some estimations based on the number of players playing per month, and I was still fitting inside my MVP benefits, let's say. So it's fine. If it will be much bigger, then I will try to think about kind of donate button or something, because I don't want to pay for something that is just for fun. So we will see, but the overall cost was below 100 euro per month in a reasonable traffic, like the one that is bigger than one person randomly visiting the page per day, but literally some people playing. So it was okay, but we will see. I really hope it will be fine to have it under 100 euro. I would love to see it much smaller, but or maybe bigger. It really depends, because as I said, some components are more costly than others, and then probably if it will be a problem, I will start to think about migrating. Maybe I don't need Cosmos DB, although it is fancy technology. Maybe symbol storage will be just better. So now I was a little bit more from the let's make it fancy and let's just control costs way of thinking, and then I will try to optimize the cost if I will really see some problems here.
Good. Let's see if some other questions will come. I have actually planned them for a good chat, but maybe one interesting. So you let me share my screen. I can do that as well, because at the end of the talk you express your hope actually. So you have that. You said that you hope that the Blazor is here to stay. Yeah, and I remember. Let me share my screen. 3 years ago, actually, that was 3 years ago, 2018. When the Blazor was still kind of experimental. I was listening to a talk given by Bedovish Adamitz and Marco Lochert. It was a very good talk about Blazor in general, and they ended with this image, like with this picture saying, "Okay, should you use this or not?" And the answer was, me personally, I'm going to hibernate for a couple of years, and wake up and see what's going to be, like I'm not here to decide. And it's 3 years since then. So let's say, it's time to wake up, What would you, you're not seeing I guess you're not seeing.
You haven't shared.
I'm sorry. This technology, I guess you should be able to see it now. So this was the image they used, and he said, like, this is what I'm gonna do, like I'm gonna hibernate for a while.
Exactly.
But I would say like 3 years are gone, so it's time to wake up. So what would be your suggestion in general? This application of a friend of yours, the modulation.
It was, let me just, because
modulation. Yeah. It surprised me because for me this is the first attempt I've seen of somebody trying to make a consumer app. That means one that goes to the end user using Blazor. Those which I've seen now in production are most enterprise apps used within a business or something, so they do not face consumers. And I'm interested in your opinion, like, you hope for Blazor, but would you bet on Blazor?
That's a very nice question, and it depends in what area I would bet on, like whether it would be something that I would like to learn to broaden my perspectives and just learn some new technology, or maybe whether I would like to try to earn money from that to be professional Blazor programmer. So for sure, that's the very common question when this talk appears, like whether we should care or maybe let's stay wait a few years more and we'll see. So the risk is yours. Like if there are some very first job offers about Blazor that is required. And then, as for every early adopter technology, you can benefit from being this early adopter. So there is no knowledge on the market, and now you know the Blazor, and although there are no many offers, you may come in and say, but I'm already proficient in Blazor. So then you can benefit for sure. But whether it is a safe path, obviously not, because if you want to take and earn money, you can simply learn Angular, JavaScript, and for sure you will find your good place to work. So if you'd like to experiment with some new technology, I would say that's one of the most interesting ones, current technologies in .NET. Because it is still web related, you can use it in web. I'm not seeing a lot of desktop development recently, although obviously it still happens. So if you are that .NET developer, which is desktop developer, which you are doing the desktop, probably you still use WPF, right? So for this particular scenario, it is your company to decide. Probably the company will not to do that, but it will wait until the MyUI grows and develops more. So this technology probably should be the one that you will be learning. But if you are a web developer and want to learn something new, and you like serverless, let's say, I would really invite you to play with this approach, because it learns you a lot of things, like how to make serverless application without really ASP.NET Core app server. So you have a Blazor app, you have an API in Azure functions, you have some database, maybe some other services, everything is serverless. If you'd like to play with that, Blazor is a perfect fit for me, I believe. So that would be not maybe for the Blazor itself, but for the whole stack that is maybe will become popular in future.
Let's see a funny comment to that from Gordon. So taking up Blazor full-time is calculated risk, I guess, but then again, bad at calculating. Last time I bet on Windows Phone, so that was the right bet.
Exactly.
or Silverlight, like many people bet on Silverlight at the time.
Absolutely.
Great. Konrad, thanks a lot. So it's already like 7:36. So I would say let's cancel this session. And bring it to the end slowly. If you have some, if you're typing right now the last question, we will wait for a second or two. But it was really interesting. I would just like to ask you for the presentation. Is it available? Is it available if you have it somewhere online to pass the link?
So I will publish it, and then we will share it probably in Meetup.
Please,
right?
Yeah, I will just share it. I will share the link in Meetup, and then. That would be it. Yeah. So maybe just as a fact, so Silverlight preferred me for Windows Phone. So that's really bad in calculating. But the nice thing is, Konrad is coming from Poland. So Gordon is actually speaking Polish. So he lived in Poland. So he actually dziękuję bardzo. That definitely so. We have a nice combination here. Thanks everybody for staying with us. Like it's nice when 30 people stay at the end of Q&A session. So we'll have a summer break now as usual and continue in September with additional talks. And Konrad, hoping to see you again with some other topic, maybe something performance related, something.
But I still remember our plans that I will come to you simply, but.
That would be perfect.
Next year or something, we will see.
Yeah, who knows? We will see. Yeah. Okay. Thanks everyone for participating, staying until the end. Konrad, thanks for being with us. And yeah, we will stop now. Thanks. Bye.
Bye.
Bye.